Have the honor to present Angelo Violetti. He's from Swisscom, and we have the honor to hear the next steps for the next generation IR and the new framework for building resilience within the Microsoft 365 world. Thank you very much, Angelo.
Thank you. Good morning, everyone. Thank you for coming here at this presentation. As already been said, we will talk about Microsoft 365, especially incident response in this kind of environment. But first of all, let me present myself. I've got more than 5 years experience in the FIR. Right now, I work for Swisscom B2B CSIRT. During the day. Then during the night, I also contribute to the FIR report. In terms of degree and certification, I've got a master degree in cybersecurity and different certification in incident response and also red teaming operation. I spoke at different conferences, including this one 2 years ago. It was really nice, so I'm really happy to be back. Probably the main ones were DEF CON 32 and also the Sans Ransomware Summit. But let's talk about the main topics. So nowadays, all 90%, I would say, of the companies more or less have adopted Microsoft 365 for collaboration, sharing files, communication. So probably everyone knows here about all of those applications, and they probably use day by day. And obviously, with the adoption of Microsoft 365, also threat actors have adapted their techniques and also the kind of attacks that they use to actually compromise companies and also gain access to their data. Here we have represented the main cyber threats and also the emerging ones that we usually identify during our day-to-day work in incident response. For sure, one of the main ones is the adversary in the middle. Adversary in the middle, it means that basically the threat actors is in between the user and also the target environment, in this case, Microsoft 365, and hijacks the communication to then gain access to the environment. So one of the information that could be stolen, obviously, are the credentials or cookies that then can be relayed into M365 and compromise the environment. Then we see a lot of internal and external spear phishing. So the compromised user accounts are then used to perform phishing campaigns because they rely on users that obviously are legitimate. So they can basically hijack the communication to then send malicious links or malicious files. Then financial frauds. So it means that the threat actor attempts to change the bank address account of transactions and then obviously gain money. Then we have got data exfiltration. Obviously, the main targets in this case are Exchange, SharePoint, and OneDrive, because whenever a threat actor gains access to the infrastructure, those files can be downloaded or even emails. And then at the end, AI. M365 Copilot vulnerabilities. A couple of months ago, a company called AM Security found a vulnerability called HLeak, which basically allows threat actor to exfiltrate data directly from the M365 Copilot chat. So since M365 is one of the main environments that we find during incident response cases, we have decided to develop solution which helps us during those investigations. And we have tried to improve our detection and also response capabilities by integrating threat detection rules and threat intelligence indicators, and also make the incident response process more efficient. So the first phase of this workflow is comprised by the registration of a Swisscom application in the customer tenant, which has been compromised, and we would like to do a compromise assessment of that. This application allows us to get specific permissions that then will give us the permission to collect all the logs that we need whenever we do an investigation. Here I listed some of them, but obviously there are way more. The main ones are the entry ID, sign-in, and audit logs, unified audit logs, which are coming from directly M365 application, and also, for example, risk detections, which are indicators that are automatically generated by M365. Subsequently, we take the logs that we have collected and we push them into our SIEM platform. The SIEM platform, first of all, performs an enrichment through threat intelligence indicators that we store in a MIS platform, and moreover also takes all the logs and applies custom threat detection rules that we have developed, but also we are still developing, because as new techniques are coming out, we will also create new detections. And then we will start the investigation based on all the information that is coming out from the third phase. Obviously, at the end of the investigation, we will create a timeline with all the list of the actions that have been identified, and also create a report. Here I wanted to show some of the features that are still under development. So the first one is obviously the log collection phase. As I said before, the main logs are obviously the ones that I showed before. However, there could be even more. It really depends on the type of case, and if we see that we will need more visibility to identify specific techniques, then we will collect additional logs. Then the second feature that we are working on is the MA client, because most of the compromise that we see are going through the adversary in the middle, which is basically implemented through phishing emails. So obviously being able to directly access the compromised user email account could really help us to find the initial access point. Third one, OneDrive file navigation, if we need to get access to any potential malicious file that has been uploaded to the customer environment. And finally, we have got the Cloud Shell. The Cloud Shell is a functionality that allows us to run directly commands into the customer environment whenever we need it, for example, to collect further logs or disable a user account or revoking their sessions. To go through this framework, we have decided to define a classic incident response scenario that we identify pretty oftenly, I would say, during our projects. So we have defined 5 phases. The first one is the adversary in the middle, so the threat actor gain access into the environment by hijacking the communication and stealing the cookies, which then allow the threat actor to bypass MFA security. Subsequently, the threat actor to be persistent in the environment, they use a new MFA device that can be added into the compromised account. Subsequently, in the middle of the kill chain, we have got the exfiltration phase, so the threat actor can, for example, set up automatic forwarding of all the emails that are coming through the compromised account, but also exfiltrating the files that are directly stored in OneDrive. And finally, the kill chain is ending up with a phishing campaign, so the threat actor tries to compromise further accounts by sending phishing emails. But as we saw before, the first phase is the application registration. So what we will do is send a specific link to the customer that they can click and then accept all those permissions that are listed right there. Those permissions are required to collect the logs and gain all the information that we need for the investigation. Subsequently, we can start doing our workflow by analyzing the first phase of the attack, which was the adversary in the middle. So the threat actors act as proxy between the user and the service to bypass the multi-factor authentication, security, and also steal session cookies. One of the detection rules that we have implemented to detect this kind of attack is whenever a user logs in multiple times from different locations in a very short period of time frame. Right here, we can see that the user that we call Miriam, obviously those are simulated, logged in from 6 different countries in 1 hour. And directly from the logs, we can see that the first logins were coming from Zurich. And then just 7 minutes later, the user logged in from the Netherlands. Moreover, if we go through the logs and we check also threat intelligence information about that IP address, we can even find out that it was a Tor node, which is obviously a service used by threat actors to anonymize their traffic. The second main detection rule that we have created for this kind of attack is obviously matching threat intelligence information, which is stored in our MISP infrastructure. In this case, the source IP was related to server used for brute forcing, and also, in this case, compromising N365 environments. The second phase that we saw before was the persistent technique. So the threat actor has to maintain their access into the target environment. And one of the techniques that can be used is like adding an additional MFA device. So the detection rule here is mainly focused on the behavior of finding additional devices whenever they are added to a user account. And as you can see in the second image specifically, we have got 2 different values. The old one, which is the below, which contained only 1 device, an iPhone 14, and subsequently we identified an additional device, an iPhone 16. So basically, a user account had 2 different devices registered for the same user. Obviously, this one could be an indicator that if the device is not legitimate, then a threat actor could have compromised the user account. Then we have got the exfiltration phase. So one of the techniques that can be used by threat actors to automatically forward the emails that are going through a specific mailbox are the so-called automatic forwarding. Obviously, there are also others, for example, inbox rules, but it's one of the ones that we have seen pretty frequently. And in this case, the behavior that we notice is that obviously the email are going through external addresses, for example, Gmail. So we have created this detection rule that whenever there is the action set mailbox forwarding rule, then we detect and generate an alert. And as you can see here, the external address was a fake one in Gmail. And obviously then all the emails that are going through the mailbox are then forwarded to the threat actor mailbox. So this is a very quick win for threat actors to exfiltrate automatically emails from a compromised user account. Another technique, obviously, to exfiltrate data is directly from OneDrive and SharePoint, which will contain sensitive information. And one of the indicators is obviously bulk download of a large amount of files in a very short period. In this case, we have got the threat actor downloaded the total amount of 90 files from OneDrive, and we can see that directly from the user agent, which also specifies transform zip, which means that basically the threat actor just clicked on a folder and then downloaded. So OneDrive, to speed up the process of downloading all the files, just created a zip archive, and then all of the files that are also a part of them listed right there have been downloaded pretty quickly. And then finally, this technique is part of, I would say, most of the campaigns that we identify. So After performing exfiltration of data, then the threat actor used the compromised user account then to perform further phishing campaigns and compromise other user accounts. Obviously, then the threat actor can also gain an economic from compromised further user accounts, because those then can be sold. So those phishing campaigns can be executed through various applications. One of the ones is EM client. EM client is loved by threat actors because it allows to basically create a sort of marketing campaigns, which obviously then can be translated into phishing. EM client, whenever it's registered and used by a user, it leaves specific artifacts. For example, in the client info string, it can be clearly see that EM client was used, and in this case, the threat actor sent various emails with the subject, "We have received a SharePoint document." Threat actor frequently uses native functionalities of Microsoft 365, like SharePoints, to then store malicious links or malicious files, because obviously they lure the victim to click on them. Based on those techniques that we have listed in the skill chain, there could be obviously different security recommendations that can be adopted by companies to either prevent, detect, or respond to those activities. We have identified 5 main recommendations specifically based on those that we have described. The first one is for sure at least enforcing phishing-resistant MFA for all the administrators, because this security mechanism can prevent attacker in the middle activities. For example, FIDO2 security keys, Windows Hello for Business, or certificate-based authentications are security mechanisms that avoid that the threat actor then can relay that information that have been stolen to the target infrastructure. Moreover, the enforcement of those policies or security mechanisms can be done through conditional access policies. The second one is the adoption of continuous access evaluation, because that's a feature in Microsoft that allows you to evaluate a user session whenever there is a condition change. So if, for example, a user logs in from a different country, from a different IP address, then Microsoft can evaluate that event and eventually perform specific actions. Third one is the implementation of strict conditional access policies whenever a user tries to add an additional device for MFA. Because what can be done is that if a user tries to perform this action, they can be prompted for another MFA code, or we can, for example, block any attempt that are coming from outside the company network, or ensuring that the action is performed from a managed or cleaned device. Fourth one is obviously the configuration of outbound spam policy. Those can restrict the automatic forwarding of emails to external recipients, or set an external message limit. Obviously, the example that we saw before with the emails that were directly filtrated to a Gmail account could be prevented through those kind of policies. And last but not least is obviously proper configuring the audit of M365 and Azure activities, because not all the logs are enabled by default, so it's important to review all the policies that have been defined and make sure that all the most important logs are at least audited and also collected into a SIEM platform, so we have got enough retention in case we have got an incident to then analyze it and identify all the actions that were performed by a threat actor. And obviously then this SIEM platform should be monitored to identify any suspicious action, and this can be done, for example, through SOC as a service, which runs 24/7, or the creation, as we saw before, of detection rules, integration of threat intelligence, IOCs, etc. So my presentation is finished. Right here, you can find my QR code for LinkedIn if you would like to connect with me. Otherwise, you can also find the CSIRT hotline number if you want to get in touch with us. Obviously, we have got also the both downstairs. So if you have got any question, obviously, feel free to ask right now. Otherwise, come to us at the booth.
Thank you very much, Angelo. Thank you very much, everyone, for being here. Are there any questions from the audience, please? Over there.
Hi, thanks for the talk. So if you deploy your application in case of when you start an investigation, you don't know at that point yet what capabilities the attacker have, and if the attack is still ongoing, how do you ensure then that your application is not getting part of the problem because of the extensive permissions you gave it?
Because we own the application is registered in our tenant, and moreover, whenever you have got a case, you at least have initial information that you can leverage to understand what has been done by the threat actor. And obviously, it's always a balance between time efficiency, responding to the threat actor, and also the requirement of the customer in terms of business. Because if the customer wants to have a quick response, because it's important for their business, then you have to follow specific procedures. If, for example, the customer does not have those requirements, then you can follow other ones, obviously.
Okay, so you took that into consideration, especially for the cloud shell and stuff. I mean, such access wouldn't be necessarily needed in any case, and it's quite a risk if you deploy something like that with a broad access to a client's tenant, right?
It is a risk, but obviously it gives you also a lot of possibility in terms of response, because if, for example, a global administrator has been compromised, then the risk is already present, especially if the customer has already been compromised. Okay. So it's always a balance between risk and what you can do in terms of response.
Thank you very much. Are there other questions? If not, I have a follow-up on, thank you, on your question. How well can you detect lateral movement if you react so quickly? I mean, you need forensic evidence, you need maybe more data. How can you balance your very much super strong administrative user with the capability to detect all you need at time of possible compromise?
First of all, what do you mean with lateral movement? Lateral movement inside the cloud or from cloud to on-prem?
Possibly both. Everything
Both.
can happen.
So inside cloud, we collect all the logs that could actually then let us to detect those kind of activities. In cloud, we especially talk about more privilege escalation than lateral movements, because whenever a cloud infrastructure has been compromised, other services then can be accessed. However, usually threat actors attempt to gain more privileges. So, for example, compromising a global administrator account instead of lateral movement. If we talk about lateral movement, we can see cases where threat actors move from cloud to on-prem, because, for example, the company use services to manage also on-prem infrastructure from the cloud. So that can happen, and if that's the case, then we will need additional logs, obviously, from the on-prem infrastructure, if those logs are not synced on cloud.
All right. Can you integrate those on-prem logs into your system, or do you have to look at them separately?
It depends on the configuration of the customer, because if the customer has an hybrid environment, then it could be possible that the logs are the Active Directory ones could be synced also on cloud, but it's not always the case. And to have more visibility, especially on the activities performed on the assets on-prem, we will need to install specific agents to then gain access to further artifacts.
Okay. Other further questions, please? Or comments from someone who is also in the SOC CSIRT environment? All right. So you basically answered all my questions in one go. Thank you. There's only one further question. If you have, for example, already a Sentinel or even new Microsoft XDR solution in place, is there a way to tweak that already into such a comprehensive response by using playbooks and so on?
It depends what kind of logs are stored in Sentinel.
Yeah, okay.
As always. If all the logs that could be sufficient to perform the investigation are already stored in Sentinel, that's great because it means that we could have enough visibility and also log like that they have got more retention than the default Azure or M365 policies. So they could give us obviously more visibility. That could be enough. Obviously, we will not need to register the application. We will perform directly the investigation from Sentinel. Obviously, that will mean that we will not have the part in the middle that we saw before in the framework, so with the threat intelligence and threat detection rules, because obviously those logs have to go through our CM to actually have those capabilities. Otherwise, if we use directly Sentinel, we can use like known queries to hunt for malicious activities.
All right, thank you. Any further questions, please? If not, I would kindly wrap up and thank you very much for your talk and your interesting insights.
Perfect. Thank you.
And we are looking forward to lunch now, so I won't keep you.